Hi, Sportster Paul here. It's Thursday, which means I get to go down and see my 100-year-old friend Shirley down in Sun City Center. So this is going to be a real quick one. More engineering disasters at Ford. So let's start with the first one. The first disaster, aluminum battery cables. And I don't even know to this day if there are any aluminum battery cables on cars. I know airplanes have them because weight's so important. But you have to understand, Ford in 1980 had a bunch of finance whiz kids that came from World War II, and McNamara, and all these people infected the company, and all that mattered was dollars and cents. No product knowledge, they weren't engineers. So then they emboldened these they hired all these product planners, MBAs, didn't love cars, could care less, and all the product planners did was try to make the car cheap. And engineers, I thought, we design cars. No. Finance people, product planners. So every year, product planner with his MBA would come down to our electrical group, and this one asked me, hey, aluminum's cheaper than copper. You know, this is a brainstorm. Can we make the battery cables in the 1980 Ford pickup, can we make them out of aluminum and save, and I'll be a big hero because I'll make all kinds of bonus from saving money. So, okay, we'll look into it. And unfortunately, there was a little continuity. It was an old timer, and he laughed. And he said, every year they come down and ask us this, some product planner. And so Body Engineering did a study. It's in that file category. Go dig. And the only way, it's the same problem you have in a house. It's the terminations. And there are a lot of burnt down houses from aluminum battery cables in houses till they understood about maybe a little lubricant and precise torque to crush it just right. And I ripped them out of this house. I put copper in, 6-gauge copper, replaced 6-gauge aluminum. Because the way they work in an airplane, they have to clad the copper. The same way they make a quarter, they put it in a train car with explosive on top and they clad the nickel-based metal to the copper center if you look on the edge of a quarter. Well, it's the same thing with these battery cables that they use in airplanes. They clad copper because that way when you crimp a terminal, it's crimping copper to copper and life is good. So to use the only kind that would take salt spray and all the reliability things we had to pass would have been these airplane battery cables, and those were way more expensive because they needed the weight. It was so more important to them. So I dug it out, sent it off to their group, and never heard from them for another couple of years, right? Until a new product planner, MBA, came and decided that this would be a great idea. So that's the aluminum battery cable. I should have shot a picture of the engine compartment. Here's the engine compartment of the 80 truck, and you can see there'd be a ground cable and a power cable, and to the relay, and then a bigger one from the relay down to the starter motor. And as a point of interest, you can see the wiper motor package. We did that wiper motor show. So you can see the packaging of the wiper motor up on the cowl. So that's the battery cable story, okay? Okay, that was a planning disaster. This is a manufacturing disaster. How hard it is to make 1 million trucks a year in 19 different assembly plants, which is what the case was back in 1980. We started getting all these failures from the field with batteries. Customer would buy the truck and the battery would boil out. Turns out the regulator was in full charge. Okay, so here's a pic of the regulator. This is an aftermarket regulator, but you can imagine it's mounted on the fender. GM mounted theirs internally to the alternator. We mounted ours on the fender. So that was the same principle as having the starter relay on the fender. Supposedly it had better reliability than when you put it on the vibrating hot engine. So here's the regulator package, and then here's another picture of a regulator removed, and you can just see the surface there, and you can see the mounting screws. So here's the deal. We start getting all these failures. Turns out, in the assembly plant, there's 2 identical screws, shape-wise. One is black, that's a black phosphate, and the other, it wasn't CAD-plated, I think it was zinc chromate. The difference is black phosphate doesn't really conduct electricity. So the assembly workers were being sloppy, and they'd pick up a whole bunch of screws, and the black, they didn't care. Maybe they'd run out of the silvery ones. It's that yellow silvery color. They take the black ones, and they'd screw the regulator in to the firewall, or into the fender there. It didn't make a ground. And the regulator, without a ground, went into full charge. And at full charge, it boils the battery out, and that's a warranty problem, so now Ford cares about it. Now, Paul, the electronics guy, I ran off and looked at the schematic, and I figured out you could add one transistor so that not only did it fail, if it didn't have a ground, it would fail no charge, but I thought this was so clever, it would also have like a trickle kind of thing through the lamp, the warning lamp on the on the dashboard. So that lamp would glow a little bit and you'd know you weren't charging, right? And I thought I was so proud of that. And I went to the managers and I'm like, oh, look at this. It's one transistor. Same thing, like the instrument panel, like all these other things. Engineers are supposed to save money, not cost money. 6 cents, 6 million cars, whatever that is, 36,000, 360,000. That's way too much money. Right? You're not going to cost us that much money, even though the regulator would be a little bit cooler, right? Because maybe in the field, I wanted to show those pictures because you saw how rusty and how gnarly that is. So same thing, if you have a rusty screw and it corrodes up there and you lose the ground, you have the same problem. So that is the voltage regulator disaster story. Not so much an engineering disaster, but in the sense of industrial engineering and production, it was. Okay, there's a theme in all these engineering disasters at Ford in 1980, and it gets back to those finance weasels and their product planner, yes men that would come over with their MBAs, no real technical knowledge. Matter of fact, they said, well, even engineering manager, you don't need a technical background because you're managing, and this is part of the disaster that happened in those, late 70s, 80s. I don't know how far it went. They're better now, I'm sure, because they learned their lesson. But if you think about it, everything, the constant, overwhelming pressure on every single engineer, every manager, make it cheap. Take cost out, make it cheap. And the reliability, I broke on the test track. Make it cheap, figure out to make it cheap. Well, guess what? You task $1 billion corporation to make things cheap. We did. And nobody wanted to buy the truck. And now you got Toyota Tundras and all Titans and all these other trucks that they didn't worry so much about cheap. They made it work. And this is, I'm told the way it worked is in General Motors, they made it work first, and then they attacked the cost. And okay, take cost out. Is there any way we can do it cheaper? At Ford, the corporate philosophy was make it cheap. So we almost know it's not going to work. And then add pennies back in. Now that was back then. Like I say, things are much more sophisticated now. And I hope those whiz kids have learned their lesson and count money and stay away from the design of trucks and cars and anything else, okay? So, Sportster Paul, thanks for watching. Little quickie one today. Catch you next time. Bye.